Hey, it's us. We're back. You liked it so much that you came back. That means a lot. What? You had to do this? I'm assigning it to you? Pish posh. All right, we're going to do learning card 2.2. So we're going to talk about the binomial formula. So we're going to kind of get a little bit more into the nitty gritty here, and we're actually going to use it to set up what we're going to be doing later in the class. So binomial formulas, PDF, CDF, mean, standard deviation, rules of thumb, etc. So 5 tosses, chance of getting exactly 4 tails. That is called our binomial probability distribution. Okay, on your calculator, that's where you do the binomial PDF. So this is binomial PDF. Okay, pretty straightforward. So that one, you're going through and you're figuring out exactly how many 4 tails. That's the formula that you did in the previous learning card. Okay. Now let's say we were flipping the coin 5 times. And so over here, what I'm going to go through and do is that, and basically this right here, for example, we're going to run down. I'm not going to keep this, I'm going to use the space here, but just, so we do binomial PDF, comma, 5.5 is we have a 50-50 chance, and then I'm going to plug in whatever x is on this. And so that's what I'm going to run through here. That's where I'm getting all of these numbers from, just so you know. So the chances of getting 0 tails out of 5 tosses is 0.03125. The chances of getting exactly 1 tail is 0.156. The chances of getting 2 tails is about 31%, so 0.312, 312. 0.156, and then back over here it's going to be 0.3125. Now, if the probability of success and failure is the same, so if you have 50-50 shot at anything, you're going to see the symmetry going on, just so you know. That's not always going to be the case, because if the probabilities are different, then it's going to shift. Now, CDF is a cumulative distribution. Okay, so this is a cumulative distribution. And so that means that, for example, so this is saying like x is less than or equal to 0. This is going to say x is less than or equal to 1. So for the, let me do one thing, put a p in there. So this is saying that p is x, p of x is less than or equal to 0. This is p of x is less than or equal to 1. So that means that you would take, for example, on this one, you would take not, it's okay to get 1 tail, it's also okay to get no tails, as long as both of those conditions are met. So when you go through and do this, so again, this is CDF, cumulative. I already said that. So like here, x is less than or equal to 0, so that's just going to be equal to whatever 0 is. Now, probability of the cumulative, so we just keep on adding the next probability into it. So like this next one, we're technically taking this 1.156 and adding it to the previous term. So it's going to be the plus the 0.3125, so we're going to end up with a rounded 0.187, which means that we have an 18.7% chance. The probability of getting 1 or fewer tails is 0.187. When we get up to 2, then we're going to take 0 and 1 and 2 and add them all up together. So when we add all of that together, you get a 50% chance of getting all of that. So if I want the probability, for example, of x being less than or equal to 3, I would take 3, I would take 2, I would take 1 tail, or I would take no tail. So you would add up all of those. So now I get 0.812, and then 0.969, and then 1.0. Okay, cumulative always adds up to 1. It always starts building up to 1. It gets bigger and bigger and bigger and bigger as you go. And it always adds to 1 because, let's face it, at the last one in the table, you've taken care of any possibility of what's going on. Okay. So calculating 4 binomials down here. So that's how those two work. That's how PDF and CDF work. And again, you know, I know you're using your calculator for a lot of that, but it's still good to know the setup for it because that's going to allow you to do some other things later on. So for calculating out mean, calculating out the mean of x when you're doing this is just basically expected value. Okay, so this is for, and again, oops, give yourself a little bit of space there. This is trials. This is probability. Okay, think expected value here. And if you think about it, it's like, you know, okay, well, if the average person, let's, you know, what's the probability of somebody bringing, you know, I don't know. So like here, you know, if you flip a coin 5 times, what's the average number of times do you expect to have tails show up? And you're going to be like, oh, well, let's see, I'm going to get, sometimes I'll get 2, sometimes I'll get 3, so probably 2.5, right? Yeah, same idea. So like in this case here, our mean of x, we're just going to take, we've got 5 trials, we've got probability of a half, so that's going to equal 2.5. That's your mean. For your standard deviation, little different. Because you got to measure out the spread here a little. Oops, let me change that color back to red. Consistency, right? So for standard deviation, variance, remember, you wouldn't take the square root, so we're going to take the square root of the variance. The variance is found by n, still number of trials, times p, still probability, times 1 minus p, which is your failure. Okay, so trials, success, and failure. So in our case here, well, that was fun. I'll edit that out. So we've got 5 trials, we've got a success of 0.5, and then we've got a failure of 1 minus 0.5. And again, I'm writing that out just so that when you're looking back, you know what's going on. So that means that our standard deviation is going to be 1.118. So again, that kind of gives you an idea. So, you know, that means that if we add and subtract that away from the 2.5, we'd go down as 1.4 up to 3.6. So you'd expect 68% of your observations would fall in that group. All right. Sorry, didn't want to cough in your ear. Now this rule of thumb, this is going to set us up for what we're doing next chapter. There are 2 conditions. So what ends up happening here, this rule of thumb says this, and it allows us to do some neat things here. You're going to look at n times p, and it should be greater than or equal to 10. So what you'd end up doing is, and you do it for both success and failure. So like in our case here, we would take, okay, is 5 times 0.5 bigger than or equal to 10? So I get 2.5 is bigger than 10. Nope. So that'd be enough to fail it. You would go ahead and check the failure one too. So again, I'm going to get 2.5, and that's not bigger than or equal to 10. Now, why are we checking that? Well, let me tell you. If we do, and if both of those work, what you can end up doing is that you can treat, if it meets this, so this is the if, then we can treat the distribution as approximately normal. And if we can do that, that means that we can then, so we can do that, and you know we can use z-scores. Oops, I forgot you guys don't like my cursive z's. You can do the z-scores, and so those are going to come with the probabilities from a normal distribution. So that means that we can do everything that we learned first semester in terms of the z-scores and stuff. We can start using that. And that's going to be how we can start checking to see if studies are valid, if what the conclusions we're making are valid, and all of that. So that's where all of this is going. All right. So that concludes card 2 for this semester. Hopefully you find it helpful. We'll see you in class. Oh, and don't forget to subscribe, like, share it with your friends, etc., etc. Hopefully, if we can get up to 200 subscribers, maybe we'll have a special video for that, right? Isn't that what all the YouTubers are supposed to say? I thought so. See you in class.